Yeah.
No, on this, you have it approaching the middle one. From the graph, it looks like it comes rather quickly to it.
If we were to take this right here, this bottom one, so I would be starting with I'd be starting at a value that's close over here, because x is my b sub t. And if I look at how much the next one changes, it's not very much. So the y value over here, so if I come up over here, this is how much I change. This is where I start, and this is how much I change. So if I'm fairly close to the equilibrium over here, the amount I change by is fairly small. As I move away from that equilibrium, as I get values for b sub t that are over here or over here, then the amount I change by is quite large. So what's happening over here, sorry Steve, is when I start off close to this equilibrium, I change fairly slowly initially, only little changes. But as I move away from the equilibrium, as those changes push me away from this equilibrium point, then I change rapidly. But then as I get close to this other equilibrium, again my changes, the rate of change slows down and it gets smaller and smaller. Does that make sense?
Yeah, that makes sense. Just saying the y-axis as a measure of the rate of change.
Yeah. Y is the rate of change. X is your value. Y is the rate at which that value is changing. Other questions about putting together an equilibrium?
Just really quickly.
Yes.
How do we know if an equilibrium is steady or unsteady, or stable or unstable?
So I look at it. That has to do with, if you want the fancy word for it, how it deals with what happens when you perturb the system.
Right. So
Also
you
known
off
as
by a little bit.
perturbation theory. So we push it off a little bit and we ask, what's going to happen if I start a little ways away from this equilibrium? In this case, I would come right back down to the equilibrium. On the other hand, when I start a little ways away from this equilibrium, I move away from it forever. I don't come back to that equilibrium, I push away from it. So when my values, if I start just a little bit off this equilibrium, they're going to push away from it. So we call that being unstable. It's like you trying to balance on a bike without moving. And when you first get on there, you're pretty close to balanced, everything's good, but you get just a little bit off balance, muscle twitches, wind comes by or whatever, and you can't keep it up. You move away from the equilibrium. On the other hand, this is you on the bike when you're moving. You're pedaling down the road, a gust of wind comes along, knocks you off of your equilibrium position, and you just naturally come right back into that equilibrium position. Keep going. So this one is what we call stable. This one is what we call unstable. We haven't seen one yet. Well, we've seen one. But if you had a situation where on one side you get close to the equilibrium and on the other side you go away from it, then we call that a saddle or a semi-stable equilibrium. And it turns out that there are even funner things that can happen. We'll have to explore some of those. Yep, we do. So we'll go ahead and take our little break and head down to 260.